students, we are here with one of the very good topic, that is what we call the electromagnetic induction. And this electromagnetic induction topic you have already done in class 10. This topic is not new for you. The word is not new for you because you have studied about it in class 10. But in class 10 you have not studied this chapter in that wide prospects which you are going to do it in class 12. Now from the examination point of view, what are the important topics that you have? If you want to note it down, you can note it down. The topics that you have is Faraday's law, that is in the syllabus. You have the Faraday's law, you have Faraday's law, you have induced EMF and current, you have induced EMF and current, you have Lenge's law, you have eddy currents and self-induction and mutual induction. So let me repeat: Faraday's law, induced EMF and current, Lenge's law, eddy current, self-induction and mutual induction. So these are the topics that you have for your electromagnetic induction. Now children, when we talk of electromagnetic induction, generally the things comes in your mind is the transformer. You remember, you must have done in class 10. Yes, transformer you did. You had done with the some of the devices. You did the devices in that chapter. If you remember, it was magnetic effects of current was given, and there you had discussed about the Faraday's law of electromagnetic induction. You did with the Lenge's law also, but maybe you must have forgotten. No worries, I'm here to help you with all such things. Now here, when we talk of electromagnetic induction chapter, what are the basic things that we expect that we should know? The basic things that we expect is a very sweet chapter. I like this chapter teaching. You know why? Because teaching electrostatics, teaching electricity, all these things, there are many things, formulas we did, many numericals problem we did, and we were very concerned about the Gauss's theorem, Gauss's law, because it happened something new to us. And there we had learnt one thing. You know what was that? That was the flux. You remember we had done with the electric flux. Electric flux, if you remember, it was the number of lines. It is a scalar quantity and it measures the number of lines of forces passing through that area, which is kept normal to that. So that was the definition for the electric flux. When we come for the magnetic flux, then let me read out the definition. It says that if we consider a plane, suppose this is your plane and it is perpendicular to uniform magnetic field. What does the word uniform magnetic field says? Uniform magnetic field means the lines of forces. Let us assume this is the North Pole and this side is South Pole. So let us, if I have assumed this as the North Pole and this is the South Pole, so lines are coming from North Pole to South Pole. You know better. This is known to you. I should not say this. Okay, so the lines are coming from North Pole entering into the South Pole. Now suppose if I keep this a plane, suppose if this is a plane, lines are going like this. Let us take one line, so it is going like this. If I keep this as normal, this is normal. Okay, so then the product of the magnitude of the field, that is what we call B, and the area of the plane. The area of the plane is giving you the magnetic flux, and more effectively we write phi is equals to, phi is the magnetic flux, that is B vector dot A vector, and when you take out this dot product, we will get B A cos theta. In my class, when I will be doing it again, I will explain you what is flux, but then again that is one thing that we are going to take care of. And then we will be studying about the laws of electromagnetic induction. Now when we deal with the laws of electromagnetic induction, there is simply one thing that you need to know: we are getting current. Okay, so by the motion of the magnet or the coil, we are getting current. This is very amazing, but if you can see some of the videos, the YouTube videos, you'll find that suppose if you have taken a magnet, and let us assume you have taken a magnet and you have taken a coil, and when the magnet is approaching or it is moving, you don't have to keep both as stationary. You have to make one move. There is a relative motion. The term relative is being used. There is a relative motion between the coil and the magnet, and because of the relative motion, what you are getting the flux generated. And when the flux is generated, then what you find that these flux is inducing the rate of change of flux, that is d phi by dt. So you have to consider a certain interval of time. The rate of change of flux is giving you electromagnetic induction, that is E. EMF, electromagnetic induction, and E is the EMF. So if you get to see the notation, E is equals to minus n d phi by dt. N is the number of the coils, numbers how many you take. D phi by dt is the rate of change of flux. So here you are getting a negative sign also. This negative sign shows that the direction is playing a very important role. I'll explain how it is playing. So there is a significance of this negative sign here. So what we really find that when you do with the electromagnetic induction, we'll be doing with the laws of electromagnetic induction, and you will get some questions, numericals based on what? You will get some numerical based on B vector, A vector will be given. Don't get afraid of this. You have already done vectors, you have already done, and it is the dot product. So phi is dot product of B vector dot A vector, and I already said it is a scalar quantity. Cos theta term you are going to get, and this cos theta term will help you to understand how the flux will be positive, negative, or zero, because theta is 0 degree, cos 0 degree is 1. If theta is 90 degree, you get this as 0, no flux. Okay, so this all things are so connected to each other that if we understand the basic, then we can easily understand many more things. We will be doing with the Lenz's law, we'll be doing with the eddy current. Eddy current is again the unwanted current that generally comes, but we are going to see that how we are going to take the advantage of this eddy current, put it into a practical approach, and there are many things that we can do with this eddy current. Then we have got the self-induction and the mutual induction. That is again with the coil. So altogether we are going to discuss in the next lecture. So before we start with the next lecture, I just want you to keep yourself, go through the topic, read the book. I always say self-help is the best help. We are there to support you, we are there, we are caring for you, we are there to make you more and more confident with your subject. But then again, your effort is very much required. You have to study, go through the chapter, read the chapter, understand. If you understand, no problem at all. Okay, so just with that, goodbye. Hope you are going to do it as you are doing it up. All my blessings are there with you. Thank you. Bye.